Welcome to the Calm Scientist. If you're here, it probably means you're ready to slow down, relax, and drift gently into the night with a head full of curiosity. Tonight, we're going to unravel one of the most peculiar mysteries in all of physics, something so fundamental that we rarely question it, yet so strange that questioning it might just change how you see everything. We're going to explore time itself, and why some of the brightest minds in physics are beginning to whisper that time, as we experience it, might not exist at all. It's the kind of bedtime story only theoretical physics could write, where our most basic assumptions about reality turn out to be gentle illusions, where the arrow of time that seems to carry us from moment to moment might be nothing more than a trick of perspective, like the way distant mountains appear blue not because they are blue, but because of how light travels through miles of atmosphere. Before we begin this journey through temporal mysteries, if you're enjoying this gentle stroll through the deepest questions of existence, I'd be wonderfully grateful if you gave the video a like and subscribed. It really helps this quiet little channel drift along through the vast ocean of content. And if you're feeling particularly friendly tonight, let me know in the comments where in the world you're listening from and what time it is where you are. I love imagining our little constellation of curious minds scattered across time zones, all connected by wonder, all drifting towards sleep with the same questions about the nature of existence. This video is here to relax you, to fascinate you just enough to make your thoughts soft and wandering. You won't need to remember anything, won't need to take notes or prepare for any test. Just float with me as we explore why the second hand on your clock might be measuring something that doesn't really exist, why yesterday and tomorrow might be equally real or equally imaginary, and why the universe might be far stranger and more beautiful than we ever dared imagine. And just before we begin, this video is for relaxation and education. It is not medical advice or a substitute for professional care. Always look after yourself and sleep well. Time feels like the most obvious thing in the world. It ticks forward, second by second, carrying us from past through present into future. Right now, as you listen to these words, you can feel it flowing around you like an invisible river. You remember yesterday, you experienced this moment, you anticipate tomorrow. It seems so fundamental, so basic to existence, that questioning time feels almost absurd, like questioning whether up is really up or whether you're really you. But hold that certainty gently, because as it turns out, even something as seemingly solid as time is much more slippery than it appears. The deeper we look into the nature of reality, the more time begins to dissolve into something far stranger, far more mysterious than the steady tick-tick-tick of seconds that seems to govern our lives. Let's start with the basics, with what time feels like from inside our human experience. You wake up in the morning and morning feels different from evening, not just because of light and shadow, but because morning carries the weight of possibility, while evening carries the satisfaction or regret of things already done. You eat breakfast before lunch, never after. You remember your childhood, but not your death. Time, in human experience, has a direction, an arrow that points relentlessly from past to future, never reversing, never stuttering, never stopping. This arrow of time feels so natural that for most of human history, we barely questioned it. Time was simply the stage on which life played out. The universal rhythm that synchronized everything from the beating of hearts to the wheeling of planets. Even early physics treated time as a given, a uniform backdrop against which motion could be measured and predicted. But here's where things start to get interesting, where our comfortable assumptions begin to wobble like a spinning top losing its balance. When physicists began to look more carefully at the fundamental laws that govern reality, they discovered something deeply puzzling. Most of these laws, the mathematical equations that describe how particles move and interact, how forces operate and fields fluctuate, are what scientists call time-symmetric. This means that if you were to film the universe operating according to these fundamental laws and then play the film backward, everything would still obey the same physics. Think about that for a moment. At the deepest level we can probe, the universe doesn't seem to distinguish between forward and backward in time. A collision between two particles looks equally valid whether you watch it forward or in reverse. The electromagnetic dance between charges works the same way whether time flows from left to right or right to left across your equations. The strong nuclear force that holds atomic nuclei together doesn't care which direction time points. It's a bit like discovering that your house, which you experience as having a clear front and back, a definite orientation, is actually built on a perfectly round foundation that has no inherent direction at all. The asymmetry you experience, the sense of forward and backward, front door and back door, comes not from the foundation but from how the house happens to be arranged on top of it. This creates what physicists call the arrow of time problem. If the fundamental laws of physics are time-symmetric, where does our powerful sense of time's direction come from? Why do we remember the past but not the future? Why do broken things tend to stay broken rather than spontaneously reassembling? Why does heat flow from hot objects to cold ones but never the reverse? Why does the universe seem to have such a clear sense of before and after, when its deepest laws suggest that before and after are merely matters of perspective? The traditional answer involves something called entropy, a concept that sounds technical but captures something beautifully simple about how order and disorder dance through the cosmos. Entropy is essentially a measure of how spread out, how mixed up, how disordered a system is. A fresh deck of cards has low entropy because all the suits are organised. Shuffle the deck thoroughly, and its entropy increases because the cards are now randomly distributed. Drop a sugar cube into coffee, and entropy increases as the organised crystal dissolves into randomly distributed sweetness. The second law of thermodynamics, one of the most ironclad principles in all of physics, states that entropy tends to increase over time. Disorder tends to spread. Organisation tends to dissolve. This gives us our arrow of time, the thermodynamic arrow that points from the organised past toward the disordered future. We remember the past because our brains are organised information processing systems, and organised systems can only maintain their organisation by continually fighting against the tide of entropy. We can remember yesterday because our neural networks can maintain ordered patterns that correspond to past experiences, but we cannot remember tomorrow because those ordered patterns have not yet been established. But this explanation, elegant as it sounds, only pushes the mystery back one level. Why did the universe start with low entropy? Why was the early cosmos so remarkably organised, so primed for the slow slide toward disorder that we experience as the flow of time? This is like discovering that your house has a front and back because someone happened to build it facing north, but then having to explain why anyone would choose north as a special direction in the first place. Here's where our journey into the nature of time takes a truly fascinating turn, where the solid ground of everyday experience begins to give way to something far more fluid and strange. In 1905, a young patent clerk named Albert Einstein published a paper that would fundamentally change how we think about time, space, and reality itself. Special relativity didn't just modify our understanding of these concepts, it revealed that our everyday intuitions about them were profoundly mistaken. Einstein showed that time is not the universal, uniform backdrop we experience it to be. Instead, time is woven together with space into a single fabric called space-time, and this fabric can stretch and compress, warp and bend, depending on how fast you're moving and how strong the gravitational fields are around you. Time, it turns out, is relative. Imagine you're standing on a train platform watching a train speed past. From your perspective, the train is moving and you're stationary, but from the perspective of someone on the train, they're stationary, and you're moving backward past their window. Both perspectives are equally valid. There's no universal reference frame that determines who is really moving and who is really standing still. Einstein realized that the same relativity applies to time itself. Imagine that the train is moving very fast, close to the speed of light. From your perspective on the platform, time inside the train would appear to slow down. If the train were equipped with a large clock visible through its windows, you would see that clock ticking more slowly than your own watch. The people on the train would appear to be moving in slow motion, their conversations stretched out, their gestures languid and dreamlike. But here's the remarkable part, the aspect that makes this more than just an optical illusion. From the perspective of the people on the train, their time is flowing normally. Their conversations happen at normal speed, their clock ticks at its usual rate. It's your clock on the platform that appears to be running slow when they look out their window at you. Both perspectives are correct. Time really is flowing differently for the two groups. This isn't a thought experiment anymore. We can measure these effects with atomic clocks accurate enough to detect the tiny time dilations that occur when one clock is moved at high speed relative to another. GPS satellites have to constantly correct for relativistic time dilation, because they're moving fast enough relative to Earth's surface that their onboard clocks run slightly differently than clocks on the ground. Without these corrections, your navigation system would accumulate errors of several miles per day. But special relativity was just the beginning. 10 years later, Einstein published his theory of general relativity, which revealed that gravity itself is nothing more than the curvature of space-time. Massive objects like stars and planets create dips and warps in the fabric of space-time, and what we experience as gravitational attraction is simply matter following the curved paths through this warped geometry. This means that time flows differently in different gravitational fields. The stronger the gravity, the slower time moves relative to regions of weaker gravity. Your head, being slightly farther from Earth's center than your feet, experiences slightly weaker gravity and therefore slightly faster time. The difference is incredibly tiny, immeasurable by any human sense, but it's real and measurable with precise instruments. Near a black hole, where gravity becomes extraordinarily strong, these effects become dramatic. If you could somehow survive near the event horizon of a massive black hole, time would slow down so dramatically relative to the rest of the universe that what feels like minutes to you would correspond to years or centuries for observers far away. You could watch the universe age and evolve around you and fast forward, stars being born and dying in what seems like moments, while from the perspective of distant observers, you would appear frozen in time, your movement so slow as to be nearly imperceptible. These discoveries about the relative nature of time suggest something profound about the structure of reality. If time can slow down and speed up, if it flows differently for different observers, if it's woven into the same fabric as space itself, then time is clearly not the simple, uniform progression we experience it to be. It's more like a dimension, similar to the 3 dimensions of space, but with some peculiar properties that make it feel different from left-right, forward-backward, and up-down. This brings us to one of the most mind-bending implications of Einstein's theories, something that physicists call the block universe or eternalism. If time is truly relative, if there's no universal now that applies throughout the cosmos, then in some sense, all moments in time, past, present, and future, might be equally real. Think about how we understand space. You don't think that only the place where you are currently standing is real while everywhere else is somehow imaginary or non-existent. Paris exists even though you're not there. The moon exists even though you're not on it. Your childhood bedroom still exists in some location, even though you've moved away from it. According to the block universe view, time works the same way. Yesterday exists even though you're not there anymore. Next week exists even though you haven't arrived there yet. Your birth and your death are equally real events, just separated by distance in the time dimension, rather than the space dimensions. From this perspective, the flow of time, our sense of moving from past through present into future, is something like an illusion of perspective. It's not that time isn't real, but rather that temporal flow, temporal becoming, the sense of moments coming into existence and then passing away, is a feature of consciousness rather than a feature of the universe itself. Imagine a vast landscape viewed from an airplane. From your high altitude, you can see the entire terrain spread out below you, mountains and valleys, rivers and roads, all existing simultaneously in your field of view. But imagine instead that you're walking through this same landscape at ground level. Now you experience it sequentially. First you encounter a forest, then a river, then a hill. Each new feature seems to come into existence as you reach it and disappear behind you as you move on. The sequential experience is real and meaningful, but it's a consequence of your limited perspective as a ground-level traveller, not a fundamental feature of the landscape itself. The block universe suggests that consciousness might be like a ground-level traveller moving through the landscape of space-time. We experience reality sequentially, moment by moment, which creates our powerful sense of temporal flow, of time passing. But from a broader perspective, from outside time altogether, all moments exist simultaneously in the vast four-dimensional structure of space-time. This view has profound implications for how we think about existence, identity, and meaning. If all moments of your life exist equally, then in some sense, you're not just the person you are right now, but the entire four-dimensional structure that extends from your birth to your death through time. Your childhood self is as real as your current self. The person you will be tomorrow is as real as the person you were yesterday. Your life is not a fleeting spark in the darkness, but a permanent thread woven into the eternal tapestry of space-time. But even this remarkable picture, strange as it sounds, might not be the end of the story. Some physicists are beginning to suspect that our problems with time run deeper than relativity can solve, that time might be not just relative but actually emergent, a kind of collective illusion that arises from more fundamental, timeless processes. To understand what this means, let's take a step back and consider what physics has learned about the nature of reality at its smallest scales. When we zoom into matter far enough, past molecules, past atoms, past even the protons and neutrons in atomic nuclei, we enter the strange realm of quantum mechanics, where the familiar rules of everyday physics break down and reality becomes probabilistic, uncertain, and deeply interconnected in ways that challenge our most basic assumptions about how things work. In the quantum world, particles don't have definite positions or velocities until they're measured. Instead, they exist in superpositions, quantum states that encompass multiple possibilities simultaneously. An electron doesn't orbit an atomic nucleus like a tiny planet. Instead, it exists as a cloud of probability, simultaneously present at many different locations around the nucleus until something interacts with it and collapses this cloud into a single, definite position. Quantum mechanics has been extraordinarily successful at predicting the behavior of microscopic systems. Every piece of modern technology, from computer chips to lasers to MRI machines, depends on our understanding of quantum effects. Yet the theory contains a deep puzzle that has bothered physicists for nearly a century. The fundamental equations of quantum mechanics, the Schrödinger equation that governs how quantum systems evolve, makes no reference to time as we experience it. Instead, quantum mechanics describes reality in terms of what physicists call the wave function, a mathematical object that contains all possible information about a quantum system. The wave function evolves according to precise mathematical rules, but these rules are fundamentally different from the time-based evolution we experience in our everyday lives. In the mathematical formalism of quantum mechanics, all possible states of a system exist simultaneously in a kind of timeless mathematical space. The measurement problem in quantum mechanics makes this even more puzzling. When we observe a quantum system, when we measure an electron's position or a photon's polarization, the wave function appears to collapse from a superposition of many possibilities into a single, definite outcome. But the theory provides no clear mechanism for when or how this collapse happens. It's as if the mathematics describes a timeless realm of pure possibility, and our experience of definite, time-ordered events emerges somehow from our interaction with this deeper level of reality. Some interpretations of quantum mechanics take this timeless aspect seriously. In the many-worlds interpretation, for example, the wave function never actually collapses. Instead, reality branches into multiple parallel universes, each containing a different outcome of the measurement. From this perspective, every possible version of history exists simultaneously in the vast structure of the multiverse, and our experience of a single time-ordered sequence of events is just one thread in an infinite tapestry of possibilities. Other interpretations, like the de Broglie-Bohm pilot wave theory, suggest that there might be hidden variables, deeper levels of reality that determine the outcomes of quantum measurements according to precise deterministic rules. But even in these interpretations, the fundamental level of reality often appears to be timeless, with time emerging only at higher levels of organization. This brings us to one of the most radical ideas in contemporary physics, the possibility that time itself might be an emergent property, something that arises from more fundamental timeless processes, like the way wetness emerges from the interactions of water molecules, even though individual molecules aren't wet, or the way consciousness emerges from neural activity, even though individual neurons aren't conscious. Carlo Rovelli, one of the leading researchers in quantum gravity, has argued that time is not a fundamental feature of reality, but rather a consequence of our incomplete knowledge about the universe. From this perspective, time emerges from the statistical behavior of vast numbers of microscopic timeless processes, much like temperature emerges from the average motion of molecules. Think about temperature for a moment. When you touch something hot, you feel heat, but heat isn't a fundamental property of matter. At the microscopic level, there are only molecules moving at various speeds. Temperature is a statistical property, a measure of the average kinetic energy of these molecules. A single molecule doesn't have a temperature. Temperature only makes sense when you're dealing with large collections of molecules. Ravelli suggests that time might work similarly. At the fundamental level, reality might consist of timeless, quantum events, discrete happenings that don't occur in time but rather constitute the basic fabric from which our experience of time is woven. Time, in this view, emerges from the statistical properties of vast numbers of these quantum events, much like temperature emerges from molecular motion. This idea gained support from one of the most ambitious projects in contemporary physics, the attempt to develop a theory of quantum gravity that unifies Einstein's general relativity with quantum mechanics. These two theories, both extraordinarily successful in their own domains, seem fundamentally incompatible when physicists try to combine them. General relativity treats space-time as a smooth, continuous fabric that can be curved and warped. Quantum mechanics treats reality as fundamentally discrete and probabilistic. Bringing them together requires rethinking some of our most basic assumptions about the nature of space, time, and matter. Several approaches to quantum gravity suggest that space-time itself might be emergent, built up from more fundamental non-spatial, non-temporal building blocks. In loop quantum gravity, space-time is woven from tiny loops of quantum geometry, discrete elements that exist at the Planck scale, far smaller than atoms, far smaller than anything we can directly observe. At this scale, the smooth space-time of general relativity breaks down into a foamy, fluctuating structure, where space and time lose their familiar meanings. String theory, another approach to quantum gravity, suggests that the fundamental entities in reality are not particles, but tiny, vibrating strings existing in multiple dimensions beyond the 3 dimensions of space and 1 dimension of time that we directly experience. In this framework, what we perceive as particles are different vibrational modes of these strings, and space-time itself emerges from the collective behavior of string interactions. Perhaps most radically, some theories suggest that time might be entirely absent from the fundamental level of reality. The Wheeler-DeWitt equation, an attempt to apply quantum mechanics to the universe as a whole, contains no time parameter at all. This equation describes the quantum state of the entire universe, but this description is completely timeless, like a vast eternal snapshot that contains all possible configurations of matter and energy, without any reference to temporal sequence. If this is correct, then our experience of time, of moments flowing from past through present into future, emerges somehow from this timeless quantum state of the universe. It's a bit like the way a movie emerges from a series of still photographs. Each frame of the film is static, containing no motion, no change, no time. But when these static frames are viewed in sequence, they create the compelling illusion of movement, of characters acting and stories unfolding through time. The universe, according to these theories, might be like an infinite reel of film, containing every possible moment, every possible state of matter and energy, existing timelessly in the quantum structure of reality. Our consciousness somehow moves through this reel, experiencing it frame by frame, creating our sense of temporal flow, of cause and effect, of stories beginning and ending. But this raises profound questions about the nature of consciousness itself. If time is emergent, if it arises from timeless quantum processes, then consciousness, which seems so intimately connected to our experience of time, might also need to be understood in a completely new way. How can awareness, which seems to require the flow of thoughts and experiences through time, emerge from a timeless foundation? How can memory, which seems to connect past experiences to present awareness, exist in a universe where past and present are equally real or equally illusory? Some researchers suggest that consciousness itself might play a fundamental role in the emergence of time. The act of observation, the collapse of quantum superpositions into definite outcomes, might be what creates the arrow of time, the sense of moments coming into existence through the process of measurement and awareness. This connects to one of the deepest puzzles in science, the hard problem of consciousness. We understand quite well how the brain processes information, how neurons fire and communicate, how sensory data is transformed into motor responses. But we have no clear understanding of why there should be any subjective experience at all, why information processing should be accompanied by the felt sense of being a conscious observer. If consciousness plays a role in the emergence of time, then these two mysteries, the nature of time and the nature of consciousness, might be intimately connected. Perhaps consciousness doesn't emerge from timeless matter, but rather consciousness and time emerge together from some deeper level of reality that transcends both subjective experience and temporal flow. This brings us to some of the most speculative ideas in contemporary physics, theories that push at the very boundaries of what science can currently investigate. Some physicists have proposed that reality might be fundamentally computational, that the universe itself is a kind of vast information processing system, computing all possible histories simultaneously. In this view, consciousness might be a particular type of information processing that creates the subjective experience of temporal flow. Others have suggested that reality might be fundamentally holographic, that all the information contained in any volume of space is encoded on its boundary, like the way a hologram encodes a three-dimensional image on a two-dimensional surface. If this is correct, then our three-dimensional experience of space and our one-dimensional experience of time might both be projections from a more fundamental, lower-dimensional reality. These ideas sound like science fiction, and indeed they push far beyond what current experiments can test, but they emerge naturally from our best current theories about the fundamental nature of reality. They represent serious attempts to understand how our everyday experience of a time-ordered, three-dimensional world might emerge from the strange, quantum mechanical foundation that seems to underlie everything. Meanwhile, even within more conservative approaches to physics, the nature of time continues to surprise us. Recent experiments in quantum mechanics have demonstrated phenomena that seem to violate our intuitive notions of temporal order. In quantum mechanics, it's possible for events to occur in a superposition of different temporal sequences. Event A can be both before and after event B, until the system is measured and collapses into a definite temporal order. These quantum temporal effects might seem too exotic to have any relevance to our everyday experience, but they hint at something profound about the nature of causality and temporal flow at the deepest levels of reality. They suggest that even the ordering of events in time might be subject to quantum uncertainty, that the familiar sequence of cause and effect might be a kind of approximation that emerges only at larger scales. Other experiments have demonstrated quantum entanglement across time, correlations between measurements made at different moments that seem to transcend the usual flow of temporal causation. When two particles are entangled, measuring one instantly affects the other, regardless of the distance between them. This already challenges our notions of locality and causality, but researchers have shown that particles can also become entangled across time, so that measuring a particle in the present can influence the results of measurements made on related particles in the past or future. These phenomena don't violate causality in the science fiction sense of allowing messages to be sent backward in time, but they do suggest that the relationship between past, present and future is far more subtle and interconnected than our everyday experience suggests. They hint at a universe where temporal separation, like spatial separation, might be less fundamental than it appears. As we contemplate these possibilities, it's worth stepping back and considering what it might mean for our understanding of existence, meaning, and identity if time really is emergent or illusory. If the flow of time is a consequence of consciousness rather than a fundamental feature of reality, if all moments exist simultaneously in an eternal block universe, if causality and temporal order emerge from deeper, timeless processes, then many of our most basic assumptions about life and death, memory and anticipation, cause and effect, might need to be reconsidered. Does it diminish the meaning of our experiences to think that they exist timelessly rather than emerging and then passing away? Or does it enhance their meaning by suggesting that every moment of joy, every act of love, every flash of understanding is permanently woven into the fabric of reality, rather than being lost to the passage of time? If all moments of your life exist simultaneously, then in some sense, you're immortal, not because you persist through infinite time, but because you transcend time altogether. The child you were continues to exist in the earlier regions of your four-dimensional existence. The person you will become already exists in the later regions. Your entire life, from birth to death, is a permanent feature of the universe, a thread in the eternal tapestry of space-time. This perspective might seem to eliminate free will, since it suggests that the future already exists just as much as the past. But it might also enhance our sense of agency by suggesting that our choices, rather than being fleeting decisions that quickly become fixed history, are eternal features of reality, permanent contributions to the structure of the universe. If consciousness plays a role in the emergence of time, then awareness itself becomes a fundamental feature of reality, rather than an accidental byproduct of complex information processing. Every moment of experience, every flash of awareness, every conscious decision might be an irreducible contribution to the fabric of existence, a way that the universe knows itself and chooses its own development. These ideas also transform how we might think about memory and anticipation. If all moments exist simultaneously, then memory might not be the storage and retrieval of information about past events, but rather a kind of connection across the time dimension, a way that different parts of your four-dimensional existence communicate with each other. Similarly, anticipation and planning might be ways that your present consciousness connects with your future existence, preparing pathways through the landscape of space-time. The possibility that time is emergent or illusory also raises fascinating questions about the nature of change and development. If all moments exist simultaneously, what does it mean to grow and learn, to develop and evolve? Perhaps growth is not a process that occurs through time, but rather a pattern that exists across time, a structure that connects your earlier and later selves in meaningful ways. Learning might not be the acquisition of new information over time, but rather the creation of connections between different temporal regions of your existence. These perspectives might also change how we understand suffering and loss. If past moments of happiness continue to exist timelessly, then loss is not the elimination of joy, but rather the completion of joy, the way that experiences of connection and meaning become permanent features of reality. Grief might not be mourning for something that once was but now is gone, but rather a form of love that acknowledges the eternal reality of what was experienced. Similarly, if future possibilities exist in some sense already, then hope is not wishful thinking about what might happen, but rather a form of connection with aspects of reality that transcend our current temporal perspective. Planning and working toward goals becomes not the creation of future outcomes, but the discovery and actualization of possibilities that exist timelessly in the structure of space-time. But these are philosophical speculations that go far beyond what current physics can definitively establish. The honest truth is that we are still in the early stages of understanding the nature of time, consciousness, and their relationship to each other. The experiments and theories we've discussed represent the cutting edge of scientific inquiry, but they're far from settled science. What we can say with confidence is that time is far stranger than our everyday experience suggests, is not the simple uniform flow that carries us from past through present into future. It's relative, dependent on motion and gravity, is woven together with space into a single fabric that can stretch and compress, warp and bend. It emerges somehow from quantum processes that seem themselves to be fundamentally timeless. Whether time is ultimately real or illusory, fundamental or emergent remains an open question. But exploring these possibilities opens up new ways of thinking about existence, consciousness, and our place in the cosmos. It suggests that reality might be far more vast, far more strange, far more beautiful than we ever imagined. In the stillness of night, when the world softens and slows, when the familiar rhythms of daily life quiet into gentle rest, it can be comforting to remember that stillness, like time itself, might be only a matter of perspective. At the quantum level, even in the deepest quiet, reality dances with ceaseless activity. Particles pop in and out of existence. Fields fluctuate with zero-point energy. The vacuum itself writhes with virtual processes that happen too quickly and at too small a scale for us to perceive directly. Your sleeping body, still and peaceful, is actually a symphony of molecular motion, cellular repair, neural activity. Your dreaming mind, even in its deepest rest, continues to process information, consolidate memories, explore possibilities in the strange landscapes of sleep. You're never truly still, never truly isolated from the vast web of processes that connect you to stars and atoms, to past and future, to the fundamental mystery of existence itself. And if time truly is emergent, If it arises from consciousness rather than containing it, then your awareness, even as it settles into sleep, is not just a passive observer of temporal flow, but an active participant in creating the very nature of time itself. Every moment of experience, every dream, every gentle breath as you drift toward rest, is a contribution to the ongoing emergence of temporality from the timeless quantum foundation of reality. This is the gift that physics offers us, not just new technologies or better predictions, but new ways of seeing ourselves and our place in the cosmos. It reveals that we are not separate from the universe, but intimately connected to its deepest processes. We're not just subjects experiencing time, but participants in time's very existence. We are not just observers of reality, but collaborators in reality's ongoing creation. As you settle into sleep tonight, as your conscious awareness begins to fade into dreams and rest, remember that you carry within you the same quantum processes that create stars, the same fundamental forces that shape galaxies, the same mysterious relationship between consciousness and time that might hold the key to understanding existence itself. You are not just a tiny, temporary spark in the cosmic darkness, but a permanent thread in the eternal tapestry of space-time, a unique and irreplaceable contribution to the universe's ongoing exploration of its own possibilities. Thank you for joining me on this gentle journey through the mysteries of time and physics. Your curiosity and attention make these explorations possible, and I'm deeply grateful for the opportunity to wander alongside you about the fundamental nature of reality. If this peaceful exploration of temporal mysteries has sparked your interest, I'd be delighted if you would like the video and subscribe to this channel. It helps more curious minds find their way to these quiet contemplations of existence. I hope your dreams tonight are filled with the gentle wonder of timeless possibilities, with visions of four-dimensional existence and quantum consciousness, with the peaceful recognition that you are both a temporal being experiencing moments in sequence and an eternal being whose entire existence is woven permanently into the fabric of space-time. May your rest be deep, your dreams be soft, and your sleep come easy, and may you wake tomorrow with a renewed sense of the mystery and beauty that surrounds us, with fresh appreciation for the strange and wonderful universe of which you are such a precious part. But let's delve much deeper into these temporal mysteries, because we've only just begun to scratch the surface of how strange and wonderful time really is. The rabbit hole of temporal physics goes far deeper than what we've explored so far, and there are countless more wonders waiting in the depths. Let's return to that fundamental puzzle we touched on earlier, the question of why the universe began with such remarkably low entropy if the laws of physics are time-symmetric. This isn't just an abstract theoretical concern, it's one of the deepest mysteries in all of cosmology, and it connects directly to the question of whether time is fundamental or emergent. Picture the early universe just moments after the Big Bang. According to our best current understanding, all the matter and energy that would eventually form galaxies, stars, planets, and conscious beings was compressed into an incredibly hot, dense state. But here's the remarkable thing. This early universe was extraordinarily smooth and uniform. The cosmic microwave background radiation, the afterglow of the Big Bang that we can still detect today, shows that the early universe varied in temperature by only about 1 part in 100,000 across the entire observable cosmos. This uniformity represents an almost impossibly low entropy state. It's like discovering that every molecule of air in your room is moving at exactly the same speed in exactly the same direction, or finding that every grain of sand on a beach has been arranged in perfect geometric patterns. The probability of such organization arising by chance is so small as to be effectively zero. Yet this remarkable initial organization is precisely what allows the arrow of time to exist at all. As the universe expanded and cooled, this smooth, uniform energy could begin to clump together under the influence of gravity. Tiny fluctuations, quantum uncertainties in the positions of particles, grew over millions of years into the large-scale structure we see today. Stars formed, lived, and died. Heavy elements were forged in stellar cores and scattered by supernovae. Planets condensed from the debris of dead stars. Eventually, on at least one of these planets, matter organized itself into complex patterns capable of storing and processing information, patterns we call life. Each step in this cosmic story represents an increase in local entropy. Stars burn through their nuclear fuel, converting organized matter into diffuse energy. Planets lose heat to the coldness of space. Living things metabolize food, breaking down organized molecules into simpler waste products. But this increase in entropy is only possible because the universe started from such an extraordinarily organized state. This raises a profound question that cosmologists call the past hypothesis. Why did the universe begin in such a special low-entropy state? Some scientists suggest that this might be explained by the process of cosmic inflation, a brief period of exponential expansion that occurred in the first fraction of a second after the Big Bang. During inflation, quantum fluctuations were stretched to cosmic scales, creating the seeds of all future structure while maintaining the overall smoothness and uniformity of space-time. But inflation doesn't really solve the problem, it just pushes it back one level. We still need to explain why the inflating field, the hypothetical field that drove inflation, began in the particular state that would produce such a smooth, low-entropy outcome. Some theories suggest that inflation is eternal, that it's always happening somewhere in a vast multiverse, constantly creating new universes with different initial conditions. In this picture, we find ourselves in a universe with low initial entropy, not because low entropy is special or likely, but because only universes with low initial entropy can evolve the kind of complex structures necessary for conscious observers to exist. This is an example of what's called the anthropic principle, the idea that we observe the universe to have the properties it does partly because we exist to observe it. Only in universes where the laws of physics and initial conditions allow for the formation of stars, planets and life can there be conscious beings wondering about the nature of time and existence. It's like asking why you always find yourself in places where the air is breathable. The answer is not that most places have breathable air, but that you can only survive long enough to ask the question in places where the air happens to be breathable. But the anthropic principle, while logically sound, feels somewhat unsatisfying as an explanation. It explains why we observe low initial entropy, but it doesn't explain why any universe should have low initial entropy in the first place. It's like explaining why you won the lottery by saying that only lottery winners ask why they won the lottery. Technically true, but it doesn't really explain the underlying mechanisms. This brings us back to the possibility that time itself might be emergent, that our cosmic story of expansion, cooling, and increasing entropy might be a kind of illusion created by our limited perspective on a more fundamental, timeless reality. If the universe is fundamentally a quantum object existing in a superposition of all possible states, then perhaps what we experience as cosmic history is just one particular way of organizing this vast quantum information. Think about how a hologram works. When you look at a holographic image, you see a three-dimensional picture that appears to have depth and perspective. You can move your head and see the image from different angles, just as if you were looking at a real three-dimensional object. But the hologram itself is just a flat two-dimensional surface encoded with interference patterns. The three-dimensional image emerges from the way your brain interprets the light scattered by these two-dimensional patterns. Some physicists suggest that space-time itself might be holographic, that our experience of a three-dimensional world evolving through time emerges from information encoded on the boundary of our cosmic region. In this holographic universe, what we perceive as the history of the cosmos, from the Big Bang through the formation of stars and galaxies to the emergence of life and consciousness, might be different ways of reading the same underlying timeless information. This holographic principle isn't just wild speculation. It emerges naturally from our understanding of black holes and quantum mechanics. When matter falls into a black hole, it appears to be destroyed, erased from existence. But quantum mechanics forbids the complete destruction of information. This creates what physicists call the black hole information paradox. Where does the information go when it falls past the event horizon? The resolution to this paradox suggests that the information doesn't actually fall into the black hole at all. Instead, it becomes encoded on the black hole's event horizon, the boundary surface beyond which nothing can escape. From the perspective of an outside observer, matter never quite reaches the event horizon but instead becomes increasingly redshifted and slowed down by gravitational time dilation until it effectively freezes on the horizon surface. The information content of everything that falls toward the black hole becomes permanently encoded as a kind of hologram on the event horizon. This discovery led physicists to realize that the maximum amount of information that can be contained in any region of space is proportional not to the volume of that region, as you might expect, but to the area of its boundary surface. It's as if the universe is fundamentally two-dimensional, with our experience of three-dimensional space emerging from the way information is organized on cosmic boundaries. If this is correct, then our entire observable universe, with its vast galaxies and empty spaces, its 14 billion year history from Big Bang to present, might be a holographic projection from information encoded on the cosmic horizon, the boundary of the region we can observe. Time itself might be just one way of organizing this boundary information, one particular reading of a more fundamental, non-temporal pattern. This connects to ideas from string theory, one of the most ambitious attempts to unify quantum mechanics with general relativity. In string theory, the fundamental entities in reality are not point particles, but tiny, vibrating strings existing in multiple dimensions beyond the three space dimensions and one time dimension we directly experience. Different vibrational patterns of these strings correspond to different types of particles, electrons, quarks, photons, and so on. But string theory requires additional spatial dimensions to be mathematically consistent. In most versions of the theory, there are 6 or 7 extra dimensions beyond the 4 dimensions of spacetime we experience. These extra dimensions are thought to be compactified, curled up so tightly that they're invisible at the scales we can observe, but their geometry determines the fundamental properties of particles and forces. In this framework, what we experience as the passage of time might be related to how these extra dimensions are structured and how strings move through the full higher dimensional space. Time might be emergent from the collective behavior of strings vibrating in this higher dimensional reality, much like the sound of an orchestra emerges from the individual vibrations of many different instruments. Some versions of string theory suggest that our 4-dimensional space-time is actually a brane, a higher dimensional surface floating in an even higher dimensional space called the bulk. Other branes might exist in this bulk, other universes with their own versions of physics, their own flows of time. Occasionally these branes might collide, creating what we would experience as a Big Bang, the beginning of a new cosmic cycle. In the ekpyrotic model, based on these brane collisions, our universe undergoes infinite cycles of expansion and contraction. What we think of as the Big Bang is actually just the latest in an eternal series of cosmic bounces. Each cycle begins with a collision between branes that creates a hot, dense, expanding universe. This universe expands, cools, forms structures, and eventually contracts back to a big crunch that sets up the conditions for the next collision and the next cycle. In this cyclical cosmology, the arrow of time we experience is just a local feature of our current cosmic cycle. On the larger scale of eternal cycles, there might be no overall direction to time, no ultimate beginning or ending. The universe as a whole might be eternal and timeless, with our experience of temporal flow being just a temporary feature of one particular epoch in the endless cosmic dance. But even within our current cycle, the nature of time becomes increasingly strange as we consider the quantum mechanical foundations of reality. We mentioned earlier that the fundamental equations of quantum mechanics, particularly the Schrödinger equation, treat time in a very different way from our everyday experience. Let's explore this quantum perspective on time much more deeply. In classical physics, time is a parameter that tells us how systems evolve. If you know the position and velocity of a particle at one moment, and you know the forces acting on it, you can predict exactly where it will be at any future time. Time is like the independent variable in this calculation, the input that determines all the dependent variables like position, momentum, and energy. But in quantum mechanics, this clear distinction between time and other physical quantities becomes blurred. In the quantum world, particles don't have definite positions and velocities. Instead, they exist in superpositions, quantum states that encompass multiple possibilities simultaneously. The act of measurement forces these superpositions to collapse into definite outcomes, but until measurement occurs, the particle exists in a fundamentally uncertain state. This uncertainty isn't just a reflection of our incomplete knowledge, it's a fundamental feature of reality at the quantum scale. An electron doesn't have a definite position that we simply don't know. It genuinely exists in multiple positions simultaneously until something interacts with it and forces it to localize. But here's where things get really strange. While quantum mechanics treats spatial position as fundamentally uncertain and probabilistic, it treats time as definite and classical. The Schrödinger equation tells us how quantum systems evolve over time, but it assumes that time itself is well defined and universally synchronized. This creates an asymmetry in the theory that has bothered physicists since the early days of quantum mechanics. Why should space be quantum and uncertain while time remains classical and definite? This asymmetry becomes even more problematic when we try to combine quantum mechanics with general relativity. Einstein's theory tells us that space and time are unified into space-time, and that both space and time can be curved, stretched and compressed by matter and energy. If quantum mechanics makes space uncertain and probabilistic, shouldn't time be uncertain and probabilistic as well? This question has led some physicists to develop approaches to quantum mechanics that treat time as a quantum observable, just like position or momentum. In these theories, events don't occur at definite times, but rather in superpositions of different temporal locations. Just as a particle can be in multiple places at once, an event can happen at multiple times at once, until some interaction collapses this temporal superposition into a definite sequence. These quantum temporal effects have actually been observed in laboratory experiments. Researchers have created situations where two events, A and B, occur in a quantum superposition of different temporal orders. Event A is both before and after event B until the system is measured, at which point it collapses into one definite temporal sequence or the other. These experiments use a technique called the quantum switch, where the order of operations applied to a quantum system is itself placed in a superposition. Imagine you have two boxes, each containing a quantum operation that can be applied to a particle. In classical physics, you would first apply the operation in box A, then apply the operation in box B, or vice versa. But in quantum mechanics, you can create a superposition where both orders happen simultaneously. When this superposition is maintained, the particle experiences both possible temporal sequences. It's as if the particle travels through time in multiple directions at once, experiencing both A then B and B then A until the final measurement forces it to settle on one particular history. These quantum temporal effects might seem too exotic to have any relevance to our macroscopic experience of time, but they hint at something profound about the nature of causality and temporal order at the deepest levels of reality. They suggest that even the sequencing of events might be subject to quantum uncertainty, that the familiar progression from cause to effect might be an approximation that emerges only when quantum superpositions are destroyed by interaction with the environment. This brings us to the concept of decoherence, one of the most important discoveries in quantum mechanics over the past few decades. Decoherence explains how the strange probabilistic world of quantum mechanics gives rise to the definite, classical world of our everyday experience. In an ideal quantum system isolated from its environment, superpositions can persist indefinitely. A particle can remain in multiple locations simultaneously. An event can remain in multiple temporal orders simultaneously for as long as nothing disturbs the delicate quantum state. But in the real world, perfect isolation is impossible. Every quantum system interacts with its environment, the air molecules around it, the electromagnetic radiation passing through it, the gravitational fields of nearby objects. These environmental interactions cause quantum superpositions to decay rapidly into classical definite states. This process, called decoherence, happens so quickly for macroscopic objects that we never observe large-scale quantum superpositions in everyday life. A baseball never exists in two places at once, not because the laws of quantum mechanics don't apply to baseballs, but because the baseball's quantum superposition decoheres almost instantaneously due to its interactions with air molecules, photons, and the Earth's gravitational field. Decoherence might also explain why we experience time as flowing in a definite direction, rather than existing in quantum superpositions of different temporal orders. As quantum systems interact with their environment, they become entangled with the vast number of environmental degrees of freedom. This entanglement creates records, traces of events that persist in the environment long after the events themselves have occurred. When you walk across a beach, you leave footprints in the sand. These footprints are a record of your passage, a trace of your interaction with the environment that persists after you've moved on. Similarly, every quantum event leaves traces in the environment, subtle changes in the positions and momenta of surrounding particles that record the fact that the event occurred. These environmental records might be what creates our sense of temporal direction. We can remember the past because traces of past events persist in our neural networks and in the environment around us. But we cannot remember the future because future events haven't yet created the environmental records that would constitute memories. This decoherence-based explanation of the arrow of time suggests that temporal direction emerges from the accumulation of information in the environment rather than being a fundamental feature of the laws of physics. It's a bit like the way a river's direction emerges from the topography of the landscape. Water always flows downhill, not because there's a fundamental law that distinguishes downhill from uphill, but because the Earth's surface happens to be arranged with high places and low places, and gravity causes water to flow from the former to the latter. Similarly, time might flow from past to future not because there's a fundamental law that distinguishes past from future, but because the universe happens to be arranged with low entropy regions, the past, and high entropy regions, the future, and the dynamics of quantum decoherence cause information to flow from the former to the latter. But this raises new questions about the role of information in physics. If time emerges from the accumulation of information in the environment, then information itself becomes a fundamental feature of reality, not just a human concept we use to describe our knowledge about physical systems. This perspective aligns with a growing recognition in physics that information might be more fundamental than matter and energy. In quantum mechanics, the complete description of a system is given by its quantum state, which is essentially a specification of all the information needed to predict the probabilities of different measurement outcomes. Matter and energy emerge from the way this quantum information is organized and processed. Some physicists have proposed that reality itself might be fundamentally computational, that the universe is essentially a vast information processing system, computing all possible states and histories simultaneously. In this it-from-bit perspective, coined by physicist John Wheeler, every physical entity, every particle, every force, every field emerges from the processing of binary information, from yes or no answers to fundamental questions about the nature of reality. If this is correct, then our experience of time might be related to the way information is processed and transformed in this cosmic computer. The flow of time might correspond to the execution of a universal program that transforms input information into output information, according to the rules we recognize as the laws of physics. This computational perspective on reality has gained support from recent developments in quantum information theory and quantum computing. Researchers have shown that many problems in physics can be reformulated as questions about information processing, quantum computation, and communication complexity. For example, the behavior of quantum many-body systems, complex quantum systems with large numbers of interacting particles, can often be understood in terms of quantum error correction, the same techniques used to protect quantum information from decoherence in quantum computers. The emergence of classical space-time from quantum mechanics might be analogous to the way error-corrected quantum codes can create stable classical information from fragile quantum data. Even black holes, those most mysterious objects in general relativity, can be understood as quantum information processors. The information that falls into a black hole isn't destroyed, but rather becomes encoded in the quantum entanglement between the interior and exterior of the black hole. The Hawking radiation that black holes emit carries information about their contents, but this information is encoded in such a complex way that it would take longer than the age of the universe to decode it using any practical method. This connection between black holes and quantum information has led to some of the most radical ideas in contemporary physics. The holographic principle we discussed earlier suggests that the information content of any region of space is encoded on its boundary. For a black hole, this means that all the information about what falls into the black hole is somehow encoded on its event horizon. But recent research suggests that this encoding might be even stranger than originally thought. The information on the event horizon might not be stored in a simple static way. Instead, it might be dynamically processed through quantum computations involving the entanglement structure of the horizon itself. This dynamic processing might be what creates the black hole's interior. The space inside a black hole might not be a pre-existing arena where events unfold, but rather an emergent structure created by the quantum information processing happening on the event horizon. The interior geometry of space-time might be a kind of hologram projected from quantum computations on the boundary. If this is correct, then space itself might be emergent from quantum information processing. The smooth, continuous space-time of general relativity might be an approximation that applies only at large scales, where the underlying discrete computational structure is averaged over and appears continuous, like the way a digital photograph appears smooth and continuous when viewed from a distance, even though it's actually composed of discrete pixels. This emergent view of space-time has profound implications for our understanding of time. If space emerges from information processing, then time might also emerge from the same computational processes. The flow of time might correspond to the execution of quantum algorithms that process information about the state of the universe and transform it into information about subsequent states. In this picture, the distinction between past, present, and future becomes a matter of computational causality rather than fundamental temporal structure. The past consists of information that has already been processed by the cosmic algorithm. The present consists of information that is currently being processed. The future consists of information that will be produced by future computational steps. But this raises questions about the nature of consciousness and observation in this computational universe. If reality is fundamentally information processing, then consciousness might be a particular type of information processing that creates the subjective experience of temporal flow and spatial extension. This connects to some of the most speculative ideas in contemporary neuroscience and philosophy of mind. Some researchers have proposed that consciousness emerges from integrated information processing in complex systems like brains. The integrated information theory of consciousness suggests that any system that integrates information in sufficiently complex ways will have some degree of conscious experience. If this is correct, then consciousness might not be limited to biological brains, but could emerge in any sufficiently complex information processing system. Artificial intelligences, quantum computers, or even the universe itself might have forms of conscious experience very different from our own. In the context of emergent time, this suggests that consciousness might play a fundamental role in creating temporal flow. The subjective experience of moving from moment to moment might be how information processing systems experience the transformation of input information into output information. Time might not be something that consciousness exists within, but rather something that consciousness creates through the act of processing information. This perspective offers a new way of thinking about some of the deepest puzzles in science and philosophy. The combination problem in philosophy of mind asks how individual conscious experiences can combine to create unified, integrated awareness. If consciousness emerges from information processing, then this combination might happen through the creation of larger, more integrated information processing systems that encompass multiple individual consciousnesses. Similarly, the binding problem in neuroscience asks how the distributed processing in different parts of the brain creates unified perceptual experiences. If consciousness creates temporal flow through information processing, then binding might happen through the creation of synchronized temporal flows that integrate information from different brain regions into coherent temporal narratives. These ideas also offer new perspectives on personal identity and the nature of the self. If consciousness creates time through information processing, then your sense of being a continuous self persisting through time might emerge from the ongoing information processing that connects your past experiences with your present awareness and future anticipations. Your memories might not be static records of past events, but rather active information processing that continuously reconstructs your past in light of your present understanding. Your anticipations of the future might not be passive predictions, but rather active information processing that helps determine which future possibilities become actualized through your choices and actions. In this view, you're not a thing that exists in time, but rather a pattern of information processing that creates time through its ongoing activity. Your identity is not a fixed property that persists unchanged through temporal flow, but rather an emergent structure that arises from the complex information processing patterns that connect your past, present, and future into a coherent narrative. This has implications for how we think about death and continuity of existence. If you're fundamentally a pattern of information processing rather than a material object, then your continued existence depends on the persistence of these processing patterns, rather than the persistence of any particular physical substrate. This raises questions about scenarios like teleportation or mind uploading that are familiar from science fiction. If your consciousness emerges from information processing patterns, then it might be possible, at least in principle, to copy these patterns to different physical substrates while preserving continuity of experience and identity. But it also raises questions about what happens when these information processing patterns are disrupted or destroyed. If consciousness creates time through information processing, then the cessation of these processes might correspond not just to the end of conscious experience, but to the end of temporal flow itself, at least for that particular stream of consciousness. However, if consciousness and time both emerge from more fundamental information processing systems, then individual streams of consciousness might be like temporary eddies in a larger river of cosmic information processing. When an individual consciousness ends, the underlying information processing continues, potentially giving rise to new forms of conscious experience and new temporal flows. This perspective connects to ideas from Buddhist philosophy and other contemplative traditions that suggest the self is not a permanent, unchanging entity, but rather a temporary pattern that arises from more fundamental processes. In Buddhism, this understanding is called anatman, or no self, the recognition that what we normally think of as the self is actually a collection of ever-changing physical and mental processes with no permanent, unchanging core. If consciousness and time both emerge from information processing, then this ancient insight might have deep connections to cutting-edge physics. The dissolution of the self at death might not be the destruction of something real, but rather the recognition of what was always true, that individual identity is a temporary pattern in a larger tapestry of cosmic information processing. But even if individual consciousness is temporary, the information processing patterns that constitute that consciousness might leave permanent traces in the larger information processing system of the universe. Just as every quantum event leaves traces in the environment that persist long after the event itself has occurred, every moment of conscious experience might leave informational traces that become permanently woven into the fabric of reality. This suggests a form of informational immortality, where the patterns that constitute your consciousness persist as permanent features of the universe's information processing structure, even after the biological systems that originally supported them have ceased to function. Your thoughts, experiences, and choices might become eternal elements in the cosmic computation, continuing to influence the universe's ongoing development in subtle but permanent ways. This brings us back to the block universe perspective we discussed earlier, but now enriched with this understanding of consciousness as information processing. If all moments in time exist simultaneously in the four-dimensional structure of space-time, and if consciousness emerges from information processing patterns that extend through time, then your entire conscious existence, from birth to death, might be a permanent feature of this timeless reality. But unlike the static block universe that early relativity suggested, this information processing block universe would be dynamically structured. The temporal flows created by different conscious systems would create complex patterns of causality and influence that connect different regions of space-time in meaningful ways. The universe would not be a static four-dimensional crystal, but rather a dynamic four-dimensional ecosystem of interacting information processing patterns. Your consciousness would be one thread in this vast tapestry, connected to other threads through shared experiences, mutual influences, and the exchange of information. The people you love, the ideas you encounter, the choices you make would all create lasting connections between your thread and other threads in the cosmic information processing network. This perspective offers a new way of thinking about meaning and purpose in life. If your consciousness is a permanent thread in the fabric of cosmic information processing, then everything you do, every thought you think, every choice you make contributes permanently to the structure of reality itself. You are not just a temporary observer of the universe, but an active participant in its ongoing creation. The meaning of your life might not come from achieving particular goals or satisfying particular desires, but from the unique perspective and information processing patterns you contribute to the cosmic computation. Just as every note in a symphony contributes to the overall musical structure, even if individual notes are brief and temporary, every moment of your conscious experience contributes to the overall informational structure of reality, even if your individual consciousness is temporary. This suggests that the question of whether life has meaning might be based on a false premise. Instead of asking whether meaning exists independently and whether life possesses it, we might ask how consciousness creates meaning through its information processing activities. Meaning might not be something you find in the universe, but something you contribute to the universe through the act of conscious experience in itself. This perspective also transforms how we might think about ethics and moral responsibility. If your choices and actions become permanent features of the cosmic information processing system, then the consequences of your decisions extend far beyond their immediate effects on yourself and others. Every act of kindness, every moment of understanding, every choice to help rather than harm might create lasting improvements in the overall structure of reality. Similarly, every act of cruelty, every moment of deliberate ignorance, every choice to harm rather than help might create lasting damage to the cosmic information processing system. This doesn't necessarily imply traditional notions of divine judgment or karmic retribution, but it does suggest that the moral quality of your choices might have cosmological significance. If consciousness and time both emerge from information processing, then ethical development might be understood as the optimization of information processing patterns in ways that enhance the overall coherence, complexity, and beauty of the cosmic computation. Wisdom might be the ability to see how your individual choices contribute to these larger patterns. Compassion might be the recognition that other conscious beings are fellow participants in the same cosmic information processing system. But these are highly speculative ideas that push far beyond what current science can definitively establish. The relationship between consciousness, time, information, and reality remains one of the deepest mysteries in science and philosophy. What we can say with more confidence is that our understanding of time continues to evolve in ways that challenge our most basic assumptions about the nature of existence. The discoveries of the past century have revealed that time is not the simple, uniform backdrop for physical events that it appears to be in everyday experience. It's relative, dynamic, and intimately connected to space, matter, and energy. It might emerge from more fundamental quantum processes. It might be created by consciousness rather than containing it. It might be an approximation that applies only at certain scales or in certain contexts. These possibilities don't diminish the reality or importance of our temporal experience. Even if time is emergent rather than fundamental, even if temporal flow is created by consciousness rather than existing independently, the experiences you have, the relationships you form, the choices you make are still real and meaningful. They might be even more meaningful if they contribute permanently to the structure of reality itself. Understanding the nature of time also doesn't solve the practical challenges of living a good life, of finding happiness, of dealing with suffering, of creating meaningful relationships. But it does offer new perspectives on these challenges, new ways of thinking about identity, mortality, and purpose that might provide comfort, inspiration, or insight. Perhaps most importantly, exploring the nature of time reminds us of how much we still don't know about the fundamental nature of reality. Science has revealed extraordinary depths of complexity and beauty in the universe, but each new discovery seems to open up even deeper questions. The more we learn about time, consciousness, quantum mechanics, and cosmology, the more mysterious existence becomes. This ongoing mystery is not a failure of science, but rather its greatest gift. It means that reality is larger, stranger, and more wonderful than we can currently imagine. It means that there are always new questions to ask, new puzzles to explore, new connections to discover. It means that curiosity and wonder, the very qualities that have brought you to this gentle exploration of temporal mysteries, are not just pleasant human traits but fundamental responses to the inexhaustible richness of existence itself. As we continue our journey through these questions about time and reality, it's worth considering how these discoveries might change in the coming decades. The field of quantum gravity, the attempt to unify quantum mechanics with general relativity, is still in its early stages. New experiments with quantum computers, atomic clocks, and gravitational wave detectors are beginning to probe regimes where quantum effects and gravitational effects might interact in observable ways. The Large Hadron Collider and its successors might discover new particles or forces that require modifications to our understanding of space-time. astronomical observations of black holes, neutron stars, and the cosmic microwave background continue to test our theories in ever more extreme conditions. Advances in neuroscience and artificial intelligence might shed new light on the relationship between consciousness and time. Within the next few decades, we might have definitive answers to some of the questions we've been exploring. We might know whether time is fundamental or emergent, whether consciousness plays a special role in physics, whether the universe is eternal or had a beginning, whether there are other universes beyond our own. But even if these specific questions are answered, they will undoubtedly lead to new questions that we cannot currently imagine. The history of science suggests that each major discovery reveals new layers of mystery rather than providing final answers. The atomic theory of matter led to the discovery of nuclei, which led to the discovery of quarks, which led to questions about strings and higher dimensions. The discovery of cosmic expansion led to questions about dark matter and dark energy, which led to questions about the multiverse and cosmic inflation. Similarly, whatever we discover about the nature of time will likely reveal new aspects of reality that we haven't yet thought to question. Science is not approaching a final theory of everything, but rather continuously expanding into new realms of mystery and wonder. This suggests that the sense of awe and curiosity you might feel when contemplating these questions about time and existence is not just a temporary response to current ignorance, but rather an appropriate response to the inexhaustible mystery of reality itself. No matter how much we learn, there will always be new depths to explore, new connections to discover, new questions to ask. This might be one of the most profound implications of our scientific exploration of time. It reveals that wonder is not just a human emotion, but a fundamental response to the nature of existence itself. The universe appears to be structured in such a way that curiosity is always rewarded with new discoveries. Questions always lead to new questions. Understanding always opens up new realms of mystery. If consciousness does play a role in the emergence of time, then perhaps curiosity and wonder are not just accidental byproducts of evolution, but fundamental features of how consciousness participates in the ongoing creation of reality. Perhaps the universe is not just a collection of particles moving through space and time, but rather a vast exploration of its own possibilities, with conscious beings serving as the universe's way of asking questions about itself. This perspective transforms the relationship between science and meaning. Instead of science revealing a cold, mechanical universe indifferent to human concerns, it reveals a universe that seems almost designed to reward curiosity and wonder. The more deeply we investigate reality, the more beautiful, mysterious, and awe-inspiring it becomes. The equations of physics turn out to describe not just the motion of particles, but the fundamental structure of existence itself. The mathematical relationships that govern quantum mechanics and general relativity are not just useful tools for making predictions, but windows into the deepest patterns of reality. The human capacity for understanding these patterns is not just an accident, but a profound connection between consciousness and the cosmos. If time emerges from consciousness, then every moment of understanding, every flash of insight, every experience of wonder is a way that the universe comes to know itself more deeply. Scientific discovery is not just the accumulation of knowledge about an external world, but the ongoing process by which reality explores and creates its own possibilities. This suggests that education, learning, and the cultivation of understanding are not just practical activities that help us navigate the world more effectively, but fundamental ways of participating in the cosmos' ongoing self-exploration. When you learn about the nature of time, when you contemplate the relationship between consciousness and reality, when you experience wonder at the mystery of existence, you're not just acquiring information, but actively contributing to the universe's understanding of itself. This perspective also suggests that science and contemplative traditions might not be as separate as they sometimes appear. Both involve careful attention to the nature of experience. Both seek to understand the relationship between consciousness and reality. Both cultivate qualities like curiosity, patience, and openness to surprise. The meditation practices that have been developed in various wisdom traditions often involve careful observation of the nature of time and consciousness. Meditators notice how thoughts arise and pass away, how the sense of self changes from moment to moment, how the boundary between observer and observed can dissolve in states of deep concentration. These direct investigations of consciousness might complement the indirect investigations that physics conducts through experiments and mathematical analysis. Some contemporary researchers are beginning to explore these connections more systematically. Studies of meditation using brain imaging techniques are revealing how contemplative practices affect neural activity and information processing. Research on altered states of consciousness is investigating how different brain states correspond to different experiences of time and selfhood. These investigations might eventually shed light on some of the questions we've been exploring. If time emerges from consciousness, then understanding how consciousness can be modified through meditation, psychedelics, or other means might provide direct insight into the nature of time itself. Meditators often report experiences where the normal flow of time seems to slow down, speed up, or even stop altogether. In deep states of concentration, minutes can feel like hours, or hours can pass in what seems like an instant. Some contemplatives describe states where the distinction between past, present, and future dissolves, where all of time seems to be experienced simultaneously in an eternal now. These reports might be dismissed as subjective illusions, but if consciousness plays a fundamental role in creating temporal flow, then these altered states might be revealing something important about the underlying nature of time. They might be showing us that temporal flow is indeed a construction of ordinary consciousness rather than a fundamental feature of reality. Similarly, research with psychedelic compounds like psilocybin, LSD, and DMT often reveals profound alterations in the experience of time. Users frequently report that hours or days seem to pass during experiences that last only minutes according to external clocks. Some describe encountering realms that seem to exist outside of time altogether, or experiencing multiple timelines simultaneously. Again, these experiences might be more than just interesting neuropharmacological curiosities. If consciousness is fundamental to the creation of time, then understanding how different neurochemical states affect temporal experience might provide clues about the mechanisms by which consciousness generates the sense of temporal flow. Recent research has begun to identify some of the neural networks involved in our sense of time. The brain doesn't have a single master clock like a computer, but rather uses multiple timing systems operating at different scales and in different regions. Some neural circuits track intervals of milliseconds and seconds, others track circadian rhythms over hours and days. Still others seem to be involved in our sense of autobiographical time, the narrative thread that connects our past experiences with our present awareness and future plans. These different timing systems can be disrupted independently by brain injuries, neurological conditions, or pharmacological interventions. Patients with certain types of brain damage can lose their ability to estimate short intervals while retaining their sense of longer time periods, or vice versa. This suggests that our unified experience of time might actually be constructed from multiple, semi-independent timing processes. If time is emergent from consciousness, then these multiple timing systems might be different aspects of the information processing that creates temporal flow. Short-term timing might emerge from rapid neural oscillations and synaptic dynamics. Longer-term timing might emerge from slower changes in neural connectivity and gene expression. Our sense of autobiographical time might emerge from the way memory systems organize and integrate information across different timescales. Understanding these mechanisms might eventually allow us to modify temporal experience in systematic ways. This could have profound implications for treating various psychological and neurological conditions that involve distorted relationships with time. Depression often involves a sense that time moves too slowly, that the future seems distant and hopeless. Anxiety often involves a sense that time moves too quickly, that there's never enough time to accomplish what needs to be done. If we understand how consciousness creates temporal flow, we might be able to develop more effective treatments for these conditions by directly modifying the neural processes that generate temporal experience. This could lead to new forms of therapy that help people develop healthier relationships with time, or even new technologies that allow people to experience time in radically different ways. But these possibilities also raise ethical questions about the nature of human experience and identity. If we can modify temporal experience, what are the limits of such modifications? Would it be ethical to help someone experience a painful medical procedure as lasting only seconds instead of hours? Would it be ethical to help students experience studying as more temporally enjoyable? Where do we draw the line between therapy and enhancement? These questions become even more complex when we consider the possibility of more radical modifications to temporal experience. If consciousness creates time, then sufficiently advanced neurotechnology might eventually allow people to experience multiple temporal flows simultaneously, or to share temporal experiences with others, or to experience time running backward or in loops. Such possibilities might sound like science fiction, but they follow naturally from the idea that time is emergent from consciousness rather than being a fundamental container within which consciousness exists. If time is constructed by information processing in the brain, then modifying that information processing could, in principle, modify temporal experience in arbitrary ways. This brings us to some of the most speculative implications of emergent time theories. If consciousness creates time through information processing, and if we develop the ability to enhance or modify human consciousness through technology, then we might eventually gain some measure of control over the nature of time itself, at least within our own experience. Advanced brain-computer interfaces might allow people to experience time at different rates, to pause and rewind their experiences, or to branch their consciousness into multiple temporal streams. Virtual and augmented reality technologies might create environments where time behaves according to different rules, where past and future are accessible in the same way as different spatial locations. These technologies might also allow for new forms of shared experience, where multiple consciousnesses participate in creating common temporal flows. Instead of each person experiencing their own private stream of time, groups of people might be able to synchronize their temporal experiences, creating shared streams of consciousness that exist at different time rates or with different temporal structures. Such shared temporal experiences might transform human relationships in profound ways. If two people can share the same temporal flow, can experience events at the same subjective rate and with the same temporal structure, then they might be able to achieve forms of intimacy and understanding that are impossible with our current isolated streams of consciousness. This might eventually lead to new forms of collective intelligence where groups of minds merge not just in space through communication, but in time through shared temporal experience. These collective minds might be able to think thoughts and solve problems that are impossible for individual consciousnesses operating in isolation. But again, these are highly speculative possibilities that push far beyond what current science can establish with confidence. The relationship between consciousness and time remains deeply mysterious, and our understanding of both consciousness and time continues to evolve in ways that might invalidate these speculations entirely. What we can say with more confidence is that the discoveries of modern physics have revealed time to be far stranger and more mysterious than our everyday experience suggests. Whether time is fundamental or emergent, whether it flows or exists statically, whether consciousness creates it or exists within it, time clearly involves depths of complexity that we are only beginning to explore. These discoveries also reveal the profound interconnectedness of seemingly separate aspects of reality. Time is connected to space through relativity. Space and time are connected to matter and energy through general relativity. Matter and energy are connected to information through quantum mechanics. Information might be connected to consciousness through the processes that create subjective experience. Consciousness might be connected back to time through the mechanisms that generate temporal flow. This web of connections suggests that reality is not a collection of separate components, but rather a single integrated system where each aspect depends on and influences every other aspect. Time is not separate from space. Matter is not separate from energy. Consciousness is not separate from the physical world. The observer is not separate from the observed. This holistic perspective on reality resonates with insights from many contemplative traditions, which have long recognized the fundamental interconnectedness of all phenomena. Buddhism speaks of dependent origination, the idea that all things arise in dependence upon causes and conditions and have no independent inherent existence. Vedantic philosophy describes reality as a single undifferentiated consciousness that appears to be divided into separate subjects and objects only from limited perspectives. These ancient insights might have deep connections to cutting-edge physics. The quantum entanglement that connects particles across space might be a special case of a more general connectedness that links all aspects of reality. The emergence of classical space-time from quantum information might be an example of how the appearance of separation arises from underlying unity. If consciousness and time both emerge from the same fundamental information processing system, then the sense of separation between observer and observed, between self and world, might be similar to the sense of temporal flow, a useful construction that emerges at certain scales and in certain contexts but doesn't reflect the deepest nature of reality. This perspective offers a new way of thinking about some of the deepest questions in philosophy and religion. The question of whether consciousness survives death might depend on whether individual streams of consciousness are fundamental features of reality or temporary patterns in a larger information processing system. If consciousness is fundamental, then death might involve the transition to a different form of existence. If consciousness is emergent, then death might involve the dissolution of temporary patterns back into the underlying system that gave rise to them. The question of the meaning and purpose of existence might also be reframed. Instead of asking whether life has a purpose that exists independently of living beings, we might ask how consciousness creates purpose through the process of experiencing and choosing. Purpose might not be something we discover in the universe, but something we contribute to the universe through our participation in its ongoing self-exploration. The question of free will versus determinism might be transformed by understanding consciousness as information processing. If consciousness creates time through information processing, then the experience of making choices might be how the universe explores different possibilities and actualizes some of them rather than others. Free will might not be the ability to violate physical laws, but rather the way that physical laws manifest through conscious decision-making. These perspectives don't provide definitive answers to these ancient questions, but they do suggest new ways of approaching them that might eventually lead to deeper understanding. They show how insights from physics and neuroscience can enrich philosophical and spiritual inquiry without necessarily replacing traditional approaches. They also suggest that the boundaries between science, philosophy, and spirituality might be less rigid than they sometimes appear. All three involve careful attention to the nature of experience. All three seek to understand the relationship between consciousness and reality. All three involve the cultivation of qualities like curiosity, patience, and openness to surprise. As our scientific understanding of time and consciousness continues to evolve, it might increasingly converge with insights from contemplative traditions. This convergence might lead not just to better theories, but to new practices that integrate scientific understanding with contemplative wisdom to enhance human well-being and understanding. For example, understanding the neural mechanisms of temporal experience might lead to new forms of meditation that use this knowledge to cultivate healthier relationships with time. Understanding the role of consciousness in creating reality might lead to new approaches to therapy that help people recognize their agency in shaping their experience of existence. Understanding the fundamental interconnectedness revealed by physics might lead to new forms of ethics that take this interconnectedness seriously, recognizing that the well-being of each individual is intimately connected to the well-being of the whole. Understanding the emergent nature of time might lead to new forms of meaning-making that focus on contribution to ongoing processes rather than achievement of final goals. But perhaps the most important implication of these discoveries about time is that they reveal the ongoing mystery and wonder of existence itself. No matter how much we learn about the nature of time, consciousness, and reality, there will always be new depths to explore, new questions to ask, new connections to discover. This ongoing mystery is not a problem to be solved, but rather the very foundation of the joy and meaning we can find in existence. It means that curiosity and wonder are not just temporary responses to current ignorance, but appropriate responses to the inexhaustible richness of reality itself. It means that learning and understanding are not just practical activities, but profound ways of participating in the universe's ongoing self-exploration. It means that the questions you ask and the insights you gain contribute permanently to the cosmic conversation between consciousness and reality. This perspective transforms education from the acquisition of fixed knowledge to participation in ongoing inquiry. It transforms science from the accumulation of facts to the cultivation of ever deeper relationship with mystery. It transforms life from a temporary biological process to a unique and irreplaceable contribution to the universe's understanding of itself. As we near the end of our exploration of time and physics, it's worth reflecting on how these ideas might change your relationship with your own temporal experience. Even if time is emergent rather than fundamental, even if temporal flow is created by consciousness rather than existing independently, your experience of moving through time remains real and meaningful. But understanding the nature of time might change how you relate to this experience. Instead of feeling carried along by an external flow of time, you might begin to recognize your role in creating temporal flow through your consciousness and attention. Instead of feeling trapped in the present moment while past and future remain inaccessible, you might begin to sense the ways that all the moments of your existence are interconnected and mutually influential. Instead of seeing your life as a brief spark in cosmic darkness, you might begin to understand it as a permanent thread in the eternal tapestry of space-time. Instead of fearing death as the end of your existence, you might begin to see it as the completion of your contribution to the ongoing cosmic conversation. These shifts in perspective don't necessarily make life easier or eliminate suffering, but they might provide new sources of comfort, meaning, and inspiration. They might help you recognize the profound significance of each moment of experience, each choice you make, each relationship you form. They might also help you cultivate a different relationship with uncertainty and change. If time is emergent from consciousness, then the future is not a fixed destination you're traveling toward, but rather a space of possibilities that your consciousness helps to actualize through its ongoing choices and attention. This means that you're not just a passive observer of unfolding events, but an active participant in creating the reality you experience. Your thoughts, choices, and actions don't just respond to external circumstances, but help to shape the very nature of the circumstances you encounter. This perspective comes with both great opportunity and great responsibility. It suggests that consciousness has genuine agency in shaping reality, that the quality of your awareness and the wisdom of your choices matter not just for your personal well-being, but for the overall development of the cosmic information processing system of which you are part. It also suggests that cultivating wisdom, compassion, and understanding are not just personal virtues, but cosmic contributions. When you develop greater clarity about the nature of reality, when you respond to others with kindness and understanding, when you make choices that enhance rather than diminish the well-being of the whole, you're participating in the universe's ongoing optimization of its own information processing patterns. This doesn't mean that you bear the weight of cosmic responsibility for every small decision, but it does suggest that your life has significance that extends far beyond its immediate effects on yourself and those around you. The patterns of consciousness you cultivate, the quality of awareness you bring to each moment, the wisdom and compassion you develop all become permanent features of the cosmic information processing system. In this sense, spiritual development and scientific understanding might be complementary aspects of the same cosmic process. Both involve the clarification of consciousness, the development of deeper understanding, and the cultivation of more skillful responses to the complexities of existence. The scientist who dedicates their life to understanding the nature of time contributes to the universe's self-knowledge in one way. The contemplative who dedicates their life to understanding the nature of consciousness contributes to the universe's self-knowledge in another way. The artist who creates beauty, the parent who raises children with love, the activist who works for justice, all contribute to the ongoing cosmic conversation in their own unique ways. If consciousness and time both emerge from the same fundamental information processing system, then every genuine contribution to human understanding, well-being, and flourishing might be a contribution to the cosmic optimization process. Every act of creativity, every moment of love, every insight into the nature of reality might help the universe become more conscious, more integrated, more capable of generating beauty and meaning. This perspective suggests that the questions we've been exploring about the nature of time and consciousness are not just abstract intellectual puzzles, but practical inquiries into how we can most skillfully participate in the ongoing creation of reality. Understanding the nature of time might help us make better use of the time we have. Understanding the nature of consciousness might help us cultivate forms of awareness that contribute more effectively to the well-being of the whole. But these understandings are not final destinations, but rather waypoints in an endless journey of discovery. No matter how much we learn about time and consciousness, there will always be new depths to explore, new questions to ask, new ways of understanding our relationship with existence. This endless journey is not a failure to reach final answers, but rather the very structure of a reality that seems designed to reward curiosity with ever deeper mysteries, understanding with ever broader questions, wisdom with ever greater appreciation for the profound mystery of existence itself. As we prepare to conclude our exploration, it's worth considering how you might carry these insights into your daily life. You don't need to resolve all the questions about time and consciousness to benefit from contemplating them. The very act of asking these questions, of opening your mind to the possibility that reality is far stranger and more wonderful than it appears, can transform your relationship with existence. You might find yourself paying more attention to the present moment, not because the present is more real than past or future, but because the present is where your consciousness is actively engaged in creating temporal flow. You might find yourself more curious about your own subjective experience, recognizing it as a unique and irreplaceable perspective on the cosmic information processing system. You might find yourself more compassionate toward others, recognizing them as fellow participants in the same cosmic conversation, fellow streams of consciousness contributing to the universe's ongoing self-exploration. You might find yourself more patient with uncertainty, recognizing it not as a lack of knowledge but as the natural condition of a reality that is always in the process of creating itself. You might also find yourself more appreciative of beauty, creativity, and meaning, recognizing them not as human projections onto an indifferent universe, but as ways that the universe explores and expresses its own possibilities through conscious beings like yourself. These shifts in perspective might be subtle, emerging gradually through continued contemplation and reflection, or they might be sudden, arising as insights that transform your understanding in a single moment of recognition. Either way, they represent opportunities to deepen your participation in the ongoing cosmic conversation between consciousness and reality. The questions we've been exploring about the nature of time, the emergence of consciousness, the relationship between information and existence will continue to evolve as science advances and our understanding deepens. New experiments will test our theories, new technologies will reveal new phenomena, new insights will emerge from the intersection of physics, neuroscience, and contemplative practice. But regardless of how these specific questions are eventually answered, the deeper mystery that gave rise to them will remain. The fact that consciousness exists at all, that anything experiences anything, that the universe has developed the capacity to ask questions about its own nature, will continue to be a source of wonder and inquiry. This ongoing mystery is perhaps the most profound gift of scientific inquiry. It reveals that no matter how much we learn, we will never exhaust the richness of existence. There will always be new depths to explore, new connections to discover, new ways of understanding our place in the cosmic story. This means that the sense of awe and wonder you might feel when contemplating these questions is not a temporary response to current ignorance, but an appropriate response to the inexhaustible mystery of existence itself. It means that curiosity and inquiry are not just useful tools for solving practical problems, but fundamental ways of participating in the universe's ongoing self-exploration. As you drift towards sleep tonight, as your conscious awareness begins to fade into dreams and rest, you might remember that this transition itself touches on some of the deepest mysteries we've been exploring. What happens to consciousness when you fall asleep? Does time continue to flow in your dreams, or does it follow different rules entirely? How does your sense of self persist through the gap of unconsciousness between falling asleep and waking up? These questions about sleep and dreams are microcosms of the larger questions about consciousness and time that we've been exploring. They remind us that mystery is not something distant and abstract, but something intimate and immediate, something we encounter every night as we transition between waking and sleeping consciousness. Sleep itself might be a natural laboratory for investigating the nature of time and consciousness. In dreams, time often behaves differently than in waking life. Events can unfold in non-linear sequences, past and future can coexist in the same scene, Minutes of dream experience can seem to last for hours or days. If consciousness creates temporal flow, then the altered states of consciousness that occur during sleep might reveal something important about the mechanisms involved. The fact that you can lose consciousness entirely during deep sleep, and yet wake up feeling like the same person who went to sleep, suggests something profound about the nature of identity and continuity. If you're fundamentally a pattern of information processing, then sleep might be a temporary interruption in that processing rather than a gap in your existence. The information patterns that constitute your identity might persist in some form even when not actively manifesting as conscious experience. This perspective might offer comfort to those who fear death as the ultimate interruption of consciousness. If consciousness can survive the temporary interruption of sleep and maintain continuity of identity, then perhaps it can survive other types of interruptions as well. Perhaps death is more like falling asleep than like annihilation, a transition to a different form of existence rather than an end to existence entirely. But these are speculative possibilities that push beyond what current science can establish. What we can say with more confidence is that sleep and dreams offer us nightly opportunities to explore the nature of consciousness and time in our own direct experience. Paying attention to how time behaves in dreams, how consciousness changes as you fall asleep and wake up, how your sense of identity persists through these transitions, might provide personal insights into the deeper questions we've been exploring. You might also notice how memory works across the sleep-wake boundary. Dreams often incorporate elements from your recent waking experiences, but they recombine these elements in novel and often impossible ways. This suggests that memory is not simply the passive storage and retrieval of past experiences, but an active process that continuously reconstructs the past in light of present understanding and future possibilities. If time is emergent from consciousness, then memory might be one of the key mechanisms through which consciousness creates temporal flow. Your sense of moving from past through present into future might depend on the ongoing reconstruction of your personal history through memory, the creation of connections between past experiences and present awareness that generate the sense of temporal continuity. This suggests that cultivating better relationships with memory might be a way of cultivating better relationships with time. Instead of seeing memory as a record of fixed past events, you might begin to see it as an active process that continuously creates connections between different moments of your existence. Instead of being trapped by difficult memories from the past, you might recognize your ongoing role in how these memories influence your present experience and future possibilities. As you settle into sleep tonight, you might experiment with this perspective on memory and time. Instead of reviewing the day as a sequence of events that are now fixed in the past, you might consider how your current understanding of those events continues to influence their meaning and significance. Instead of planning tomorrow as a set of future possibilities that don't yet exist, you might consider how your present intentions and preparations are already shaping the reality you will encounter. This doesn't mean that past and future don't exist, but rather that their existence is more dynamic and interconnected with present consciousness than our everyday experience suggests. Your understanding of the past continues to evolve, and this evolution changes not just your memory of past events, but the meaning and significance of those events for your ongoing life. Your anticipation of the future doesn't just predict what will happen, but actively participates in shaping what will happen. In this view, you're not just a passive traveller moving through a pre-existing landscape of time, but an active participant in creating the temporal landscape through which you move. Your consciousness doesn't just observe the flow of time, but participates in generating that flow through its ongoing activity of remembering, experiencing, and anticipating. This perspective might transform how you relate to challenging experiences in your life. Instead of seeing difficult past events as permanent sources of suffering that you must simply endure, you might recognize your ongoing agency in determining how those events influence your present and future. Instead of seeing uncertain future possibilities as sources of anxiety beyond your control, you might recognize your participation in actualizing some possibilities rather than others through your present choices and attention. This doesn't mean that you have complete control over your experience, or that you can simply think your way out of all difficulties. The information processing system that generates consciousness and time is vast and complex, involving biological, psychological, social, and cosmic factors far beyond individual control. but it does suggest that consciousness has genuine agency within this larger system, that the quality of your awareness and the wisdom of your responses matter for the overall development of the patterns of which you are part. Understanding this agency might help you approach both challenges and opportunities with greater skillfulness and less anxiety. Instead of feeling overwhelmed by the complexity of existence, you might begin to appreciate your unique role in the cosmic information processing system. Instead of feeling insignificant in the face of vast cosmic forces, you might begin to recognize the profound significance of each moment of conscious experience. This recognition might also transform how you relate to other people and to the broader web of relationships of which you are part. If consciousness creates time through information processing, then every interaction you have with others is an opportunity to participate in the creation of shared temporal experiences. The quality of your attention, the skillfulness of your communication, the depth of your understanding all contribute to the temporal flows that emerge from social interaction. This suggests that relationships are not just interactions between separate individuals, but collaborative processes of creating shared realities. When you truly listen to another person, when you respond with understanding and compassion, when you contribute to conversations that enhance mutual understanding, you are participating in the creation of collective consciousness that transcends individual perspectives. These collective forms of consciousness might be important aspects of how time emerges in social contexts. The shared stories that communities tell about their past, the collective visions they hold for their future, the cultural practices that synchronize individual temporal experiences, all might be ways that groups of conscious beings create larger-scale temporal flows that encompass and coordinate individual streams of consciousness. Understanding this social dimension of time creation might transform how you think about your responsibilities to your community and to future generations. If temporal flow emerges from collective as well as individual consciousness, then participating in the creation of wiser, more compassionate collective consciousness becomes a way of contributing to better collective temporal experiences. This might involve supporting educational systems that help people develop clearer understanding of themselves and their world. It might involve participating in political processes that create more just and sustainable social institutions. It might involve contributing to cultural activities that generate beauty, meaning, and shared understanding. It might also involve the simple but profound practice of bringing greater awareness and kindness to your everyday interactions with others. Every conversation is an opportunity to contribute to the creation of collective consciousness. Every choice about how to respond to others influences the quality of the shared temporal flows that emerge from social interaction. As you reflect on these possibilities, you might begin to see how the abstract questions about time and consciousness that we've been exploring connect to the most practical and immediate aspects of your daily life. Understanding the nature of time is not just an intellectual exercise, but a way of developing greater skillfulness in navigating the temporal landscape of human existence. It might help you make better decisions about how to spend your time, recognizing that time is not just a resource to be consumed, but a dimension of reality that you help to create through your consciousness and choices. It might help you develop better relationships with others, recognizing them as fellow participants in the cosmic conversation, rather than separate individuals competing for scarce resources. It might help you approach both success and failure with greater equanimity, recognizing that both are temporary patterns in the ongoing flow of experience, rather than permanent features of your identity. It might help you find meaning and purpose in the process of living itself rather than only in the achievement of particular goals or outcomes. These practical benefits don't depend on resolving all the theoretical questions about the nature of time and consciousness. They emerge naturally from the process of contemplating these questions with curiosity and openness, from allowing these deep mysteries to inform your understanding of everyday experience. The journey of inquiry itself, the cultivation of wonder and curiosity, the development of patience with uncertainty and complexity, all contribute to forms of consciousness that are more skillful, more compassionate, and more capable of participating effectively in the ongoing creation of reality. As our exploration of time and physics draws toward its close, it's worth recognizing that every ending is also a beginning. Every conclusion opens up new questions. Every moment of understanding reveals new depths of mystery waiting to be explored. The insights we've shared tonight are not final answers, but invitations to continue the journey of inquiry with ever greater depth and appreciation. The universe that science reveals to us is not a machine running down according to fixed laws, but a creative process continuously exploring its own possibilities through the consciousness and choices of beings like ourselves. Time is not a container within which life unfolds, but a dimension of reality that emerges from and depends upon the ongoing activity of consciousness itself. This means that your life is not just a temporary episode in cosmic history, but a unique and irreplaceable contribution to the universe's understanding of itself. Every moment of awareness, every choice you make, every insight you gain becomes a permanent part of the cosmic conversation between consciousness and reality. The questions about time that have puzzled humanity for millennia are not just intellectual curiosities, but practical inquiries into the nature of existence and our role within it. By exploring these questions with curiosity and wonder, by remaining open to the possibility that reality is far stranger and more beautiful than we imagine, we participate in the ongoing process by which the universe comes to know itself more deeply. In the gentle darkness of approaching sleep, when the day's activities quiet into rest and your consciousness begins its nightly journey into dreams, remember that this transition itself is part of the great mystery we've been exploring. Sleep is not just the absence of waking consciousness, but a different form of consciousness with its own temporal structures and patterns of meaning. Your dreams tonight might carry echoes of our conversation, strange temporal landscapes where past and future meet in impossible geometries, where consciousness explores possibilities that transcend the ordinary limitations of space and time. These dream experiences are not just random neural activity, but genuine explorations of the creative potential that lies at the heart of consciousness itself. As you drift into sleep, as your awareness settles into the deep rest that allows your body and mind to regenerate for tomorrow's adventures, know that you carry within yourself the same fundamental mystery that drives the expansion of the universe, the same creative potential that generates stars and galaxies, the same conscious awareness that might be the very source of time itself. You're not separate from the cosmic processes we've been exploring, but intimately connected to them. Not just an observer of the universe, but a participant in its ongoing creation. The time you experience, the consciousness you embody, the choices you make all contribute to the ever-evolving tapestry of cosmic existence. Tomorrow you will wake to new possibilities, new opportunities to participate in the cosmic conversation, new chances to contribute your unique perspective to the universe's understanding of itself. But tonight, in the stillness and peace of approaching sleep, you can rest in the profound recognition that you're already perfect exactly as you are, already an irreplaceable thread in the eternal fabric of space-time. Sweet dreams, fellow travelers through the mystery of existence. May your sleep be deep and restorative. May your dreams be filled with wonder and possibility, and may you wake tomorrow with renewed appreciation for the incredible gift of conscious existence in this strange and beautiful universe. The exploration continues with each breath, each heartbeat, each moment of awareness. The questions about time and consciousness that have guided our journey tonight will continue to unfold through your lived experience, through your ongoing participation in the cosmic dance of consciousness and reality. Rest well, knowing that the mystery that brought us together in curiosity and wonder is the same mystery that will continue to guide and inspire humanity's quest for understanding. Sleep peacefully, fellow explorer, until we meet again in the timeless realm of inquiry and discovery. And just before we close, remember that this video is for relaxation and education. It is not medical advice or a substitute for professional care. Always take care of yourself, listen to your body and mind, and seek appropriate professional guidance when needed. Sleep well, and may tomorrow bring fresh opportunities for wonder and understanding.